Okay, since I'm going to be gone today, you're going to go ahead and watch this video to go over your notes. What you need to do right now is in the top left of your next clean page in your notebook, you need to write down this do now. Write all of it down so you have everything for your example. And then go ahead and pause the video so that you have a chance to attempt it before I go over it. Make sure that you are finding X and each segment length. Do not just stop at X. Make sure you're plugging it back in to find the rest of it.
Teachers make mistakes too.
Okay, when we go ahead and draw this, you're going to draw a line with L, P, and Z on them since they are collinear. Since Z is between P and L, you need to make sure that somewhere in the between those 2 points is where you put Z. So I'm going to go ahead and draw this segment. P and L need to be on the ends, and then again, anywhere you want in the middle, we'll call it right there, is going to be Z. When we start to fill in our information, it tells me that ZL is 2x minus 6. So I'm going to put that between Z and L. PL, which is from end to end, so that is the whole thing, is 3x minus 1. And then ZP is equal to 9. So I'm going to put that right here. When you're doing this, remember that it is always part plus part equals whole. So my two parts are these pieces, the 9 and the 2x minus 6. That needs to equal my whole, which is the 3x minus 1. When you solve this, make sure you combine your like terms first. So this 9 and the negative 6 need to go together. So it's really going to be 2x plus 3 equals 3x minus 1. If you subtract the 2x over, you get x minus 1 equals 3. And then moving the 1, x is equal to 4. To get each length, remember because I do want each segment length, I already know ZP is 9. To get ZL, I'm going to do 2 times 4, which is 8, minus 6, which is 2. And then to get the entire length of PL, 3 times 4, which is 12, minus 1, which is 11. One thing to always make sure, your two parts should add together to equal the total. Since ZP is 9 and ZL is 2, that adds to equal 11, which means I probably did it correctly. Since I am not here today, we're going to go over your homework answers next time after I get a chance to go through and stamp your homework. So what you're going to do right now is make a pile of your homeworks at your table. Make sure your name is on them, and then you're going to pass them to the sub so that I can collect them. I will go through them and give them back to you, and then next class we will go over the correct answers to your homework. So make sure all your homework gets turned in right now. Once you've had a chance to turn in your homework, go ahead and write this title on your page if you have not done that already. Today we're going to kind of continue on with our segment and angle addition into something that's a little more specific when we're dealing with bisectors. So make sure this title is in your notebook. I'm going to give you a few definitions first, and then we're going to draw some things, and then we're going to do some examples. So your first definition is a midpoint. A midpoint is the point located, oopsies, that is not how you spell located, halfway between two objects or points. They could be whatever you want them to be. Okay? What this really tells you, I'm going to give you a picture here so you can kind of see what it's talking about. If I have this line segment right here, and say I have point X and Y are my endpoints. If M is the midpoint, it is halfway between X and Y, which tells you that XM is congruent to YM. Where that's going to help us today is if I say I knew that this side part over here, this XM, is 5 centimeters, which you automatically know since this is 5 centimeters on the left, it has to also be 5 centimeters on the right. Okay, we're going to apply that quite a bit today. Here I just want you to have a basic picture in your notes of what this looks like. So if I tell you midpoint, it's talking about the point halfway between two objects. So it tells you that the distance on either side of it is exactly the same. A segment bisector does pretty much the same thing, but it's a little bit more specific in terms of what it's looking like. A segment bisector is a geometric object that intersects a segment at its midpoint. Okay, so what this is going to look like, feel free to pause this to give yourself a chance to write this down. Say I have a segment XY, and XY is bisected. It has a segment bisector, potentially this one, ZW. ZW is the bisector. It is the segment bisector of XY, which means that wherever ZW hits XY has to be the midpoint. I'm going to make it M again. Okay, where this is helpful, again, is that if M is the midpoint, these two parts are exactly the same. So this is still, like in the last example, if the left is 5 centimeters, so is the right. So if you are given the word segment bisector, it is telling you the exact same thing as if I tell you midpoint. Okay, what's important is to know which one was bisected. So knowing that XY was cut in half in this example because it was bisected by ZW. But again, it really just tells you that the two different parts are exactly the same measurement. Your last definition that we're going to go through here is an angle bisector. An angle bisector is a geometric object that bisects an angle. Okay, bisects tells you that it was cut in half. So there's really two definitions there to make sure you got them. Okay, an angle bisector is a geometric object that bisects an angle, and bisects means it was cut in half. You will have really one kind of picture for all of these, so I'm going to go ahead and draw you an angle first. Okay, say you have this angle, we'll name it angle A, B, C, and it is bisected by, we'll fill in a nice little ray here. Make this dash for you. Bisected by ray BX. Okay, what that tells you is that ABX, this top part, is exactly the same as XBC, this bottom part. Okay, so again, I have angle ABC. I'll even write this one out for you. Angle ABC is bisected by ray BX. This is the picture you would get from that, and then it would really tell you that this top angle is congruent to this bottom angle, so you can go from there with your problem. What I want you to do now is go ahead and draw me this picture. Write down these words, and then draw me the picture that it is describing. Once you've done that, you're going to mark for me everything that is congruent so that I can make sure you can go ahead and do that. So pause the video so you have a chance to do that, and then I'll go through the correct answer here. Okay. We have an angle. I always start with my angle here, so draw angle LMP. So I'm going to draw this angle LMP. Based on the name, we know that M is the vertex because it's in the middle. It does not matter if you put L above or below, but we know that M is the vertex. Okay, then it tells me that this ray MO, so M is the endpoint of the ray, like it tells you in the name. This ray MO bisects this angle. It really doesn't matter how you draw it. What matters is how you mark it after. Okay, but since MO bisects the angle, MO should be in the middle. To mark my congruent parts, this top part then is congruent to the bottom part. So angle LMO is congruent to angle OMP. What that tells you again is if this top angle is 50, so is the bottom angle. If the top angle is 97 degrees, so is the bottom angle. You might not know what they are yet, but you do know they are exactly the same. Okay, make sure you have that picture in there. Next one, go ahead and draw me this picture. and make sure you can put everything in the correct spot. Do make sure you mark your congruent parts, because there is a tricky part to this one that I want to make sure you got. Again, pause it so you have a chance to go ahead and mark that into your notebook and label all your congruent parts. Okay, first thing you got to draw is this segment AB. Okay, then AB is bisected, so AB is what is bisected, so we should expect AB to be cut in half. It is bisected by this ray XY, so XY is my segment bisector, and AB is my thing that is cut in half. So if I fill in this ray right here, X is my endpoint, Y is somewhere else on my ray. Okay, and it intersects AB at this point C. Now what's super important here is the congruent parts. AB is what was cut in half. So when you mark your congruent parts, you know that AC is congruent to CB. You do not know anything along XY because I don't know if XY was cut in half at all. I don't know really anything about that. I do know that AB was cut in half, so the only congruent marks you should have on this one are along AB. What we're going to do now is go ahead and try some algebra problems with these, because there's a few different setups we're going to look at. Okay, the first thing I want you to do is write this down. Whenever we start these problems, we are going to go ahead and draw our picture first. Okay, so when we draw this, first off, I'm looking at this, and B is the midpoint of AC, so I'm going to go ahead and draw my segment first. So I have AC, and B is the midpoint. So I am going to try to draw it in the middle, just to make it look like it makes sense. And I like to mark things that these two parts are congruent. Since B is the midpoint, I know these parts are the same. I may not know what they are yet, I don't really know anything in my problem, but I do know that my parts are the same. So when I go to fill it in with my information, AB is X, and BC is 3X minus 12. Okay, now last time when we set up these problems, we always did part plus part equals whole. But when I look at this problem, I don't have my whole value at all. So I can't set up part plus part equals whole. However, I do know that both my parts are equal because we know that B is the midpoint. What that means we can do, we have a different way we can set up the problem. We can just set up part equals part. Now the only reason you can do this is because you were given the word midpoint. You can do it other times because of bisects, but you cannot do it if you only know between, like we talked about last time. So make sure you have the word midpoint if that's the case. Okay, so now we know that X is one of my parts. We know my other part is 3X minus 12. Then we can go ahead and solve this. What we can do, we can subtract that 3X over and get negative 2X equals negative 12. Which gives me that X equals 6. Okay, read the directions always. This tells me to find AC. AB is the easy one to plug into. We know that has to be 6. The nice thing here, if AB is 6, we automatically know that BC has to be 6 as well. To find AC then, you can just add those together. So AC has to be 12. Okay, so again, we could set this one up differently because we knew midpoint, so we knew each of those halves had to be congruent, and then we could solve our problem from there. To give you another picture, go ahead and write this one down and try to draw it first. If you haven't had a chance to finish drawing it, go ahead and pause the video, but I'm going to fill in the correct one. Okay, when I read this sentence, it tells me AB bisects XY. So reading that, XY is what was cut in half. So I'm going to draw XY. I'm going to draw another segment here. I always like to make my thing that was cut in half be horizontal. So here's XY, here's AB, and it was bisected at point C. So again, what I now know is that XC is congruent to X, or to CY. When we go to fill in our information, XC is 2X minus 2. And xy, which is now the whole thing, that's why I always draw this little line below, is 3x plus 1. Now when I look at this, we can't set these equal like we did before because one's the whole thing and one's just a part. So we are going to have to do part plus part equals whole like before, but we do need to figure out how we're going to get our missing information. Okay, I have a first part, 2x minus 2. I have the whole, but I don't immediately obviously have the other part. However, if you look at this a little closer, I do know that xc is congruent to cy, which means I know that they're the same no matter what. So what I can actually do is fill in this 2x minus 2 for cy as well. Okay, and now that gives me a whole equation that I can actually use. So when you ever have a part and a whole, remember that your two parts have to be the same, so you can fill that part in on both spots. When we go ahead and fill in our equation, we're going to combine our like terms first. So I have 4x minus 4 equals 3x plus 1. We're going to go ahead and solve this. It's going to give you x minus 4 equals 1, and then x equals 5. Pay close attention to what it asks for every time. So we do want x, that's important. We're going to box that up. But it also wants each segment length. So if I want to find xc, we're going to do 2 times 5 minus 2. 2 times 5 is 10, minus 2 is 8, which means that cy has to be 8 as well. It's always a good idea to check this, so I'm going to plug this in even though I could just add them together and figure it out. So 3 times 5 plus 1, 3 times 5 is 15, plus 1 is 16, so xy is 16. Again, a nice check, make sure 8 plus 8 equals 16, so my two parts do actually add together to equal my whole, which is good news for my problem. Okay, going on to the last example, fill this one in for me. Try to draw that picture to the best of your ability first, so pause the video, draw the picture, even attempt to fill in those different parts and set up that equation, and then we'll go through the rest of it together. So when I draw this one, I'm going to draw my angle first, so ABC is my angle. B has to be the vertex because it's my middle point. And then it tells me that BD bisects ABC. So BD has to be here. Okay, and what that tells me, like we talked about before, is ABD, this top one, has to be congruent to DBC because of the word bisects. That bisects is super important. If I fill in my measurements that I know here, I know ABD, if you trace it out, is this top one. ABD is 5x. DBC, or this bottom angle, is 3x plus 6. Okay, remember with these bisects and midpoint problems, you really have two ways to think about setting it up. You're either going to do part plus part equals whole, if like on the last problem you're given a part and a whole, or you're going to do part equals part if you're given both pieces. Looking at this problem, when we filled it in, I didn't give you a whole at all, so you can't do part plus part equals whole, and we are going to have to do part equals part, which works because we do in fact know these are congruent. When we go ahead and fill this in, one of the parts is 5x, the other part is 3x plus 6. When you solve it, you're going to get 2x equals 6, or x equals 3. Okay, if we want to find measure of angle ABD, 5 times 3 gives me 15 degrees. If you plug it in below just to double check, 3 times 3 is 9, plus 6 is 15. Okay, and I also could have asked you for all of ABC if I wanted to. ABC would be 15 plus 15, or 30 degrees. Okay. I'm going to put this video on Canvas so that you have access to it if you need it for any more reference for questions that you may run into. On your homework, you need to pay very close attention because there are going to be some problems from today that are bisects or midpoint, and there are going to be other ones like last time that are just regular segment and angle addition problems. So pay very close attention to the wording we give you so that you know if you can set your parts equal or if not in that specific problem. You're going to have the rest of class to go ahead and work on your homework.